right, let's talk about the unit circle. Unit 14 of our semester, of our year, last topic on the semester exam. Determine the value of the trigonometric function. So you will not be given a unit circle. You need to do this without a unit circle. If you need to, the things that I would draw on your paper, if need be, would be the signs for each quadrant, and then potentially even the ordered pairs for the quadrantal angles. And finally, I would, if you need to, if you don't use the left-hand trick, you can draw in the first quadrant, right? So the first quadrant here for, let's write the angles, I guess. Pi over 6, pi over 4, pi over 3. Okay, so the ordered pair here would be radical 3 over 2, 1/2. The second point is radical 2 over 2. And then 1/2 radical 3 over 2. Now, if you know those, you don't have to write any of this down. But if you're going to write something down, that's really all you need to do. You can use your left-hand trick, but all of that information right there will answer all these questions. Now, let's talk about the trig values. Cosine of 5 pi over 6. First of all, cosine is an x value, so we're going to look at the x coordinate of these ordered pairs. 5 pi over 6 references pi over 6. So I'm going to grab a highlighter here really quick once it pops up. Oh. Well, pi over 6 is going to be this bottom ordered pair here. Okay. So all the pi's over 6's, I'll highlight them now, are all going to use the yellow ordered pair. Maybe we'll do all those at the same time. So cosine of 5 pi over 6. So cosine is the x-coordinate, so it's going to have something to do with radical 3 over 2. That's the x-coordinate for the reference angle. Now, 5 pi over 6 is, the numerator is 1 less than the denominator, so it's in quadrant 2, not quadrant 3, quadrant 2. And in quadrant 2, the x value, didn't switch. The x value is negative in quadrant 2. So we would have a negative radical 3 over 2. Okay? Let's get down here to 4. 7 pi over 6. Well, sine of 7 pi over 6 is dealing with a y value. So we're looking at the 1/2 of that ordered pair. And 7 pi over 6 is in quadrant 3. And in quadrant 3, the y value is negative. So our answer would be negative 1/2. For number 6, pi over 6. Well, that's in quadrant 1. That's just going to use that ordered pair right there. The sign is the y. So all we have there for the y value is 1/2. Okay. Let's look at our next ordered pair, 7 pi over 4. So 7 pi over 4, it froze again. 7 pi over 4 is dealing with the middle ordered pair. And this is our only 7 pi over 4 here. All right, so we have sine, which is the y value. So we're looking at radical 2 over 2. Now, 7 pi over 4 is 2 times 4 minus 1. So it's in quadrant 4. And in quadrant 4, the y value is negative. So we're going to have a negative radical 2 over 2. Let's jump down to number 5, then I'll go back to our 3 pi over 2. Cosine of 4 pi over 3. Well, 4 pi over 3 uses the last ordered pair here. I don't know. I guess you can still kind of see it in green. 4 pi over 3 has the reference angle of pi over 3. Cosine is the x-coordinate. So we're going to look at the 1/2 here. And 4 pi over 3, the numerator is 1 more than the denominator, so we're in quadrant 3. In quadrant 3, the x value is negative. So I'll have a negative 1/2. All right, finally, cosine of 3 pi over 2. Now, 3 pi over 2 is a quadrantal angle. You need to know where 3 pi over 2 is. And that is actually down here on the very bottom. It's the negative y-axis. So we use the ordered pair 0, negative 1. Well, cosine is the x. So the x value of that ordered pair right there is 0. All right, hopefully that makes some sense. I know it's hard when it's on the video and I can't do the left-hand trick, but hopefully color coding and using the first quadrant there was helpful. Now, all we're going to do in these next ones is write the equivalent degree measure of each of the following radians. It says all of these degree measures are on the unit circle. So, here's how this is going to go. 2 pi over 3. Now, if you need to draw a picture of things for yourself, remember, this is, I'm going to do degrees here. I'll do radians too, but 0, 90, 180, 270, and 360. Then we can think about pi's too, right? 0 pi and 2 pi, pi over 2, pi, and 3 pi over 2. All right, so if I think about 2 pi over 3, well, pi over 3, bear with me here, pi over 3 is in the first quadrant. And 2 pi over 3 is in the second quadrant. Now, we're looking at degrees here. Pi over 3 is 60 degrees. So if I'm working, say I start at 180 and I'm working up, that means I would have to subtract 60 degrees from 180 to get to 2 pi over 3, which is 180 minus 60, 120 degrees. All right, so I'm going to erase those. Nope, I don't have any other pi over 3s, so we're good. All right, now, let's talk about the next one, 7 pi over 6. Well, pi over 6, we'll just think about where it's located. Pi over 6 is right here. That's 30 degrees. Now, if I have 7 pi over 6, that's going to be in quadrant 3 because the numerator is one more than the denominator. It's actually going to be right here. Now, 7 pi over 6, if you couldn't remember your unit circle, 180 degrees since it's pi, that would be like 6 pi over 6, which is 1 pi. So 7 pi over 6 is 30 more degrees from 180. So 180 plus 30 would be 210 degrees. All right. The next one. Oops, I don't want to erase too much for that. Okay, 7 pi over 4. All right, so that references pi over 4, which is here in the first quadrant. Pi over 4 is 45 degrees. And 7 pi over 4 would be in the fourth quadrant because it's 2 times 4 minus 1. So you can think about it this way. Here I went up 45 degrees. If I'm in the fourth quadrant, that means I have to subtract 45 degrees from 360. And 360 minus 45 would be 315 degrees. All right, last two. Pi over 4. Well, that one's really easy. Pi over 4 we just talked about. It's here in the first quadrant, and pi over 4 is equal to 45 degrees. You should just know that one. That should take not a lot of thought. Finally, 3 pi over 2 is one of your quadrantal angles. It's down here on the bottom. That's 270 degrees. So those take a little less thinking and figuring out than the other ones. All right, last couple. Number 12, we're going to state all of the quadrantal angles in degrees and in radians. So that's actually what we just had down here on our picture. So the degrees would be the 0, 90, 180, 270, and 360. Okay? So you should know that all those multiples of 90 are your quadrantal angles. Those are the degrees. Now in radians, again, those are your pi's. The 0 pi and 2 pi, pi over 2, pi, 1 pi, 3 pi over 2, and 2 pi. Those are your quadrantal angles in radians. All right, finally, let's see, we're going to say the quadrant where all of these radians occur. That's really important for when you're doing the first part here, which was the trig, without using a unit circle. 7 pi over 6 is going to be in quadrant 3 because the numerator is one more than the denominator. And remember, we said there was a pattern with radians where the first quadrant, the numerator was always pi. The second quadrant, the numerator was always 1 less. The third quadrant, the numerator was 1 more than the denominator. And the fourth quadrant, you would go times 2 minus 1. So if we have 2 pi over 3, the numerator is 1 less than the denominator, so that's quadrant 2. 5 and 3, when I compare those, Well, that would be 2 times 3 minus 1, so that's quadrant 4. Same with 16. 7 is 2 times 4 minus 1, so that's quadrant 4. And pi over 6, the numerator of just pi, is in quadrant 1. All right, let us know if you have any questions. See the key on Canvas or ask your teacher for help.